Thanks for stopping to look at my research poster. In a nutshell, my poster highlights three things. I investigate peripersonal space, or PPS, with a focus on autism and development. My research makes use of virtual and augmented reality. And I developed a novel method to measure PPS. It has cross-population and lifespan applicability. PPS refers to the near-body space we consider our actionable space, or where things feel close enough to reach, grab, or react to. It's like your brain's personal bubble, which it monitors closely. There is heightened response to stimuli, faster reaction time. PPS bridges perception and action. For example, if a ball flies in your direction, your brain quickly figures out if it's in your bubble and what to do about it. Should you avoid it or interact with it? This animation shows how this bubble is flexible and keeps recalibrating. This adjustment process may be less flexible in autism, which impacts body awareness, spatial manipulation, object avoidance and social interaction. These are the superficial areas thought to be involved in PPS, and our neural targets while engaged in a PPS activity. Now, moving to our novel measure. We are using both VR and AR versions of the task. The task is very simple and intuitive.
You will be popping bubbles. You can pop them with your right hand like this, or with your left hand like this.
Each bubble is presented within a cone-like zone, and there are two task conditions. In the static trials, bubbles appear at different distances. This tests spatial integration using a reach-based task. The key measure is contact distance. How close the bubble gets before the participant decides to act. This reflects a behavioral PPS boundary, a decision point shaped by comfort, confidence, or hesitation. In short, it reveals how far someone is willing to act under uncertainty. In the dynamic trials, bubbles approach at varying speeds. This probes temporal integration under looming pressure. Key measures are reaction time and motor onset timing. Faster RTs may reflect urgency, slower ones, delayed processing. Motor onset timing reveals not just if participants act, but when they initiate movement, marking the temporal boundary of PPS engagement. Coming to initial pilot data. The TLDR version of the graphs is that my novel bubble measure works. Each figure shows some insight. I invite you to watch my other short video on these graphs using animations. Why is our bubble task a useful and novel measure? The task captures RT and contact distance, revealing when people act and how close they let stimuli get. Motion trials simulate looming stimuli, tapping multi-sensory integration under pressure. Participants reach and pop, providing richer data than passive detection tasks. At our outreach event, kids as young as 5, and adults of all ages, genuinely enjoyed popping virtual bubbles. That's more than anecdotal. It shows the task requires minimal instruction, reducing experimenter bias, and is developmentally adaptive. It works across motor and cognitive neurodevelopmental disabilities, including, potentially, higher support autistics. It informs VR and AR tools for motor, spatial and social support across settings. A little brag with a touch of humility, since we are still in pilot. This bubble task is actually a more direct and, dare I say, a better way to measure PPS. We plan to validate against an established PPS task. Both use looming stimuli and reaction time but differ in responses type. Passive tactile versus active reach to touch. Bubble pop expands the construct with richer, action-based data. Thank you.